Hello, my name is Vadim, and in this video I show you how to work with one of my assets. I hope this will help you in your work and save time or make it your work comfortable. The asset is designed to attach points to polygons by clicking the mouse in the viewport, and all attached points will undergo transformation that occur with the polygons before they are connected, meaning you can rotate and so on. All transformations will also be applied to the points. The asset accepts unpacked geometry with a primitive attribute X form with 4x4 transformation matrix for each primitives. Here is the implemented as follows. The X form in the include is the detail, and then in the promote node I move it from detail to primitives. If for some reason this attribute is missing on the incoming geometry and there is no way to create it, the asset can create it itself. Go to the incoming geometry tab. There are two toggles here. I'll explain later what the difference between them is. Enable one of them in the asset. You will need to set the name of the attribute what will have some unique identifier. If you have multiple objects and you need to place points on several objects, the asset distinguishes between them in this way. Create a connectivity node and create a primitive attributes. Let it be class. Let it remain. Disable it, enter the class here, delete the previously created points, and add any new one. As we can see, everything remains the same, meaning points are added, and all transformations are also translated to these points. Later on I'll come back to this, and for now, let's look at the functionality of the asset. To do this, let's set up a basic setup without connectivity, without the toggle enable. Let's delete all unnecessary transformations here, remove any extra points that were created, and so on. The first parameter on the group allows adding created point to different groups. Currently, the parameter is empty, so all newly created points will not belong to any group. But if we enter some group here, for example test, then all newly created points will be added to the test group. Here we can see it. If we enter test2 here, then all newly added points will be added to the test2 group. You can see how some geometry appears because I am attaching geometry to this group through the copy to points node. Turning off unnecessary flags, and here we'll see geometry behind added. I guess it will be better to demonstrate it. This value becomes somewhat default for newly created points, meaning newly created points will be added to this group. Also, when you this toggle on, the group parameter also appears in the individual parameter for each point. I previously created points here, and initially they weren't added to any group because the group parameter was empty. Here it's evident that it's remained empty. You can add any group you want here at any time or modify existing one because the lower points, let's go back to them, are already added to an existing group. You can change the group to creation points here, add 3 here, and let's add 1 here, and there will be red parameters. So changes are available in the individual parameter for each point after creation if you decide to change the point's membership to a group after creation. The next parameter copy of the primitive normal on which the point is placed to the set point. Perhaps you might find this data useful and you'll use them. This functionality is available for such cases. The next parameter, offset, is essentially the point's position offset in the direction of the primitive normal on which this point is placed. The parameter has a default value of 0 and works the same way as with groups, so all newly created points will have offset. For example, 0.2. I see there already a defined offset. Offset multiplier is like a multiplier for the individual offset parameter value of each point, meaning if points were previously created with some value, the asset will consider them. The parameter just multiplies the offset value of all points, taking into account their previously values. There is also an activate toggle called align custom axis. It's active only when toggles custom axis or look at are enabled. The parameter change the direction of the offset. Turn on custom axis, and now Our offset axis is set to R1 along the y-axis. All geometry is aligned along the y-axis. If we turn on Align Custom Axis and multiply the values, we can see that the offset will occur not along the primitive normal but along this value. If I want to offset somewhere, I offset in that direction. Turn it off, the offset occurs as usually along the primitive normal to which the point is attached. The next parameter is attribute. It's float only, originally conceived as p-scale, so it was this default name. It worked the same way as with groups. That is, when a toggle is on, all newly created points will have this value. Now, everything disappeared because the points that were already created have a zero values, meaning zero size. So, we don't see anything, and to apply this value to all already created points, use the Apply to All button. Here, randomization of parameter values is also provided when toggling on random attribute. From the moment you toggle this on, all PSK parameter value will be random between the minimum and maximum. So this value attribute will not work here, and all newly created points will already have some specific random PScale. Let's remove the XCs and try to create again. You see they all already have some difference in size within the range between the maximum and the minimum. I want to create a group of points between 0.2 and 0.5, and they turn out quite small. We need to create a size between 0.8 1.3. Let's create such a random. After you've created the points, you can also adjust the value and the individual parameter of each point. If you don't like any of the values, you can additionally adjust it for each point individually. The next parameter in this line is align to primitive, and turn it on. Align all the geometry that is fed through copy to points node on the primitive plane to which this geometry is attached. When this toggle is enabled, a new parameter instance height is available. Here it's already set, meaning it's just the height of the instance geometry fed through copy to points node, and it also take into account the values of the p-scale attribute, and all the instance geometry will be aligned to the plane of the primitives regardless of their different size. This is convenient if you need to add various sized geometry to a polygonal object surface so that these instances are on the surface on the polygonal objects. In this case, of course, there is overlapping of polygonal because the addition occurs at the sum position. But this can be adjusted using the offset multiplier parameter. Add some small offset to avoid this overlap. You can also set your own attribute name. It doesn't necessarily have to be p-scale. You can use own names for your purpose, but unfortunately in this version the attribute can be only point and only float. Okay. Let's move on the next parameters line, and the next parameter line is rotation. Turn on the toggle and set the rotation angle, which rotate the geometry connected to copy to points node via quaternion. The default rotation axis is the primitive normal on which the point is placed. This can be used to create some animation. Let's set it to 5 here. Let it be 720 degrees. Well, and we get something like this. That is, movement and simultaneous rotation. These values can also be randomized. Turn on randomized rotation, set the minimum and maximum angle. Let's animate them too. It will be 316 and let's say 720. We can see here that each point has its own individual rotation angle. That is, the instance geometry rotates not by a comma value, but each instance geometry has its own individual rotation angle, and it is convenient to use, for example, if you need cover a certain area with a forest and you have only one model of tree. To make it look natural, each tree should have its own unique rotation angle. Turn on rotation, set the minimum and maximum rotation angle, and each newly added instance geometry will have its unique rotation angle. You can make it close to all the other, or with a small deviation, or with a large deviation, as you wish. You can also set an individual rotation angle for each point. When you turn on rotation in individual parameter for each point, a new parameter appears. This parameter is inactive, and to activate it, you need to turn on the Activate toggle. Here, the rotation angle is set individual for each point. This is convenient to use, for example, if you need to animate some gears on moving objects, and these gears should rotate asynchronously. That is, the rotation should have opposite values to look natural. You can link this to the angle parameter and make one the value negative, leaving the other positive, and control the rotation speed through the angle parameter. Use scenarios may be different. Here in these parameters, you can also set a custom rotation axis by turning on the custom axis toggle. I'll turn off offset multiplier, set it to 0 here, and we can see that rotation now occur along the y-axis, where individual values are not set. Remove active and see that rotation occur along the axis directed according to this vector parameter. There is also another toggle here that is inactive if you have custom axis enabled. It's called Look At. If you ever work with a similar function in camera, this works the same. I'll demonstrate an example using the Add node. Let's create a point, copy its position, paste it here, and try moving the point. When you turn on the custom axis toggle, all points have the same axis of rotation. When you activate the Look At toggle, the calculation occurs from the position where the point is placed to the position specified in this vector parameter. Let's turn on the offset animation again, enable along custom axis, and add a few more points to make it look more presentable. Let's start the timeline and play with it in real time. I hope the parameters in this line are also clear. Perhaps this concludes my review of the asset functions. Next, I will tell you about some of the features of the work. The first thing I'd like to mention is that point placement is quite fast, and if you need to place a point in a specific position, try to not move the mouse cursor while clicking. Suppose you need to place a point with precision here. Carefully click without moving the cursor, otherwise if you move the cursor, you may end up with something like this. Let me know, and in future versions, I'll add customizable delays to control this and make it comfortable for everyone to work with. Next, let's look at some asset control elements. In the asset, there is a parameter called number of points. This is the number of points planned to be added. Suppose we need to add 10 points. The message window above shows the number of points you can place. That is, when we place points, the value decreases. This indicates how many points are left available for placement. When we place all 10 points, a message will appear indicating the next 8 more points, or you can press the reset button. Let's make it not 10, but 20 points. That means we'll add 10 more additionally. When you start placing points, the counter will begin counting the remaining points considering the additional ones. To remove added points, use the reset button. Avoid using the clear button, as it will simply delete the planned number of points you intend to add. If the value here is 0 and you try to add points, you will receive an information message stating that you need to input a value other than 0 and try again. If you input, for example, 10 and try again, everything will work fine and the counter will start counting the remaining points. Now, as I mentioned at the beginning, I'll tell you about the incoming geometry tab. Specifically, about the difference between these two toggles. Let's connect another incoming geometry, remove axis points, and set the planned number of points to 100. I have this TSD bit animation, supposed to have been assigned to 8 point to an animated object that doesn't have an X-form attribute. Then, you need to go to the incoming geometry tab and enable the getXForm toggle. Add the connectivity node if it's not there. And now you can place point every during animation, whatever you want. The difference lies in the fact that the function enabled by the getXForm toggle takes only one primitive for each object and calculates the transformation matrix based on one primitive. Then this matrix is applied to all primitives of the object. If your object is, for example, a cube and it remains a cube without any deformations during animation, then use this function. It will work faster. However, if your cube has changed scaling, rotation, or any twist during animation, meaning it somehow changed its shape, then use the X-form for each primitive toggle. In this case, the transformation matrix will be calculated for each primitive. This will require more computational resources, but will give you much greater accuracy if you are using animated object that deform. Also, for example, if you already know a specific group or specific polygons where you need to place point to reduce load and increase efficiency, you can remove axes primitives using the blast node and leave only those primitives where you need to add points. In this case, it's worth using Xform for each primitive, since there will be a few primitives and the calculation will be faster. That's about it. Thank you very much for your attention. I hope this asset proves useful to you.